The two-sample z-test. Are two calibrated production lines different enough to rule out chance? A two-sample z-test compares the means of two independent numerical populations. When both populations' standard deviations are known from information external to the samples. It tests a pre-specified mean difference, implemented here as 0. This condition is uncommon. Large samples do not turn sample standard deviations into known population values. And an independent two-sample t-test is normally used when either sigma must be estimated. The null implemented is h0, mu1 minus mu2 equals 0. The numerator x bar 1 minus x bar 2 measures the observed difference, and the denominator combines independent known variance contributions. Covariance would be needed if samples were paired or otherwise related. Under h0 and the normal model, z follows the standard normal distribution. The p-value is a tail probability for statistics, at least as extreme under h0, not the probability that the groups have equal means or that randomization failed. Use the procedure for two independently sampled or independently assigned groups, a numerical outcome, and genuinely known sigma 1 and sigma 2 that apply to the current populations. Each row should belong to one group only. Interpret the sign relative to sample 1 minus sample 2, and report both sample means so the direction is transparent. The z magnitude shows how large the difference is relative to its known standard error. A rejection supports evidence for the stated directional or two-sided alternative at alpha. It does not measure practical value or establish causation without a randomized design. Failure to reject leaves the difference unresolved rather than demonstrating equality. Two independent calibrated lines produce the same component. Historical validation supplies sigma 1 equals 3 grams and sigma 2 equals 4 grams. Samples are line 1, 101, 103, 100, 102, 104, and line 2, 98, 100, 99, 101, 97. A two-sided comparison at alpha equals 0.05 was planned. Enter the two samples and known standard deviations. The sample means are 102 and 99 grams, so the observed difference is 3 grams. The known standard error is the square root of the sum of two terms. 3 squared divided by 5 plus 4 squared divided by 5, giving square root of 5, about 2.236. Therefore, z approximately 1.342, and the two-sided p-value is around 0.18. Because p exceeds 0.05, the test fails to reject equal population means. The 3-gram observed gap is not sufficiently extreme relative to the known variability and small sample sizes. The experiment provides insufficient evidence at the planned threshold that the two-line means differ. It does not show the lines are equivalent and does not assess whether a 3-gram difference is operationally acceptable. The external sigma values and independence between sampled units must remain applicable. Try it free at distryscope.com.